when it comes to evaluating limits with vertical asymptotes, there often isn't much algebra that needs to be done. More or less, we're just going to be understanding what's going on and looking either at a sign chart or even still a graph or both to figure out what's up. So basically, I wanted to start this just discussing the usual simple examples at x equals 0, and then of course thinking about when we have more complicated functions, these are just sort of translations and whatever, stretch, shrink, translations of this same sort of behavior. So if I'm looking at a function 1 over x cubed, 1 over x is something with an odd power, that's going to look like this, right? I've got this asymptote, it's going positive, and it's going negative, right? So from the left, I'm going to the negative side, negative infinity. From the right, I'm going to positive infinity, because those are the signs of x, right? When I have instead a positive, even power, 1 over x squared, 1 over x cubed, then I'm going to positive infinity, not 1 over x cubed, 1 over x squared, 1 over x to the fourth, right? 1 over x cubed would look like that. 1 over x to the fourth, or 1 over x squared, it's going to look like that, because the even power is going to kill the negative sign. So that's something that's very obvious that we've known for a long time. So we're just now using the language of limits with something that we've known for a long time. So what do I mean, though, when I'm talking about, oh, here's an asymptote? You know what's happening. The function is growing without bound because the bottom is going to 0 and the top is staying constant, right? So if I have a number over 0, this is going to either positive or negative infinity, depending on the sign of the thing. So that's when you're going to have an asymptote, a vertical asymptote. So what does this mean to me, like if I'm going to do a problem, right? Let me give you an example. What happens here? So if I'm asked to find the limit as x goes to 3 from the negative side, something like this. If I go ahead and just plug in 3 the way I've been doing, what do I get? I get 9 minus 16, and then I get 9 minus 6 minus 3, so I get negative 7 over 0. Okay, well, so that's going to tell me I've got something, a finite number over 0, that's going to tell me this is approaching infinity. Is it approaching negative infinity or positive infinity? I need to know that to get the right answer. You might think that because there's a negative there, oh, it must be going to negative infinity. But we just plugged in this number. Plugging in a number doesn't tell me anything about which direction I'm going to or anything. So in order to figure out what's going on, what I really need to do is a sign chart. So I'm going to do a sign chart here. In order to do the sign chart, I have to factor. So here I've got in the top x minus 4 and x plus 4. In the bottom, it's going to be x minus 3 times x plus 1. You can immediately see that I'm going to get a 0 when I put in 3, right? So you can tell 0, the rest aren't 0. This is definitely going to be a vertical asymptote. On my sign chart, I've got zeros and asymptotes at negative 4, negative 1, 3, and 4. I don't actually need to finish the sign chart for everything, right? All I need to know, my question is about what's going on at 3. All I need to know is what's going on in this region because I'm heading towards 3 from the left. So all I need to know is the sign here. I don't care about the rest. I don't even have to do the whole sign chart. All I have to do is pick a point in between here. Oh, I can pick 0 because it's really easy. So I evaluate this thing at 0, right? That's negative, that's positive, that's negative, that's positive, negative, and positive is positive here, right? So that is all I need, and now I know that my answer is positive infinity. If instead I was going to 3 from the right, then I would figure out this region. I would find out that that's negative, and then my answer would be negative infinity. So you see, this didn't help me. This helped me only because I realized, oh, I've got a vertical asymptote because I'm dividing by 0. I'm dividing a finite number by 0. Okay? It's the sign chart and figuring out which direction I'm going to that asymptote that is going to tell me whether I'm going positive infinity or negative infinity. So that's what is going to happen with a rational function. And based on the sort of ideas talked about, like 1 over x to the n, 2n, or 2n minus 1, you can sort of see that. But I can actually be more general. Whenever I'm going to have a number over 0, it is going to be going to positive or negative infinity. I just have to figure out which one. So if I had limit as x goes to 2, right? I have to figure out this. I actually don't even have to do much because I can see that this isn't even defined on the left for x less than 2, and for x greater than 2, it's always going to be positive. So this is going to be positive on this domain. It's going to 0, so it's going to be infinity, right? If I want to think about it, I can think about that sign chart. These numbers are always going to be positive. Okay, so I took it first. I said natural number. It can be a rational number for sure, but you again have to be careful about things when I talk about domain. If I had asked for this, this makes no sense. It doesn't even exist because there's no numbers there. So limit doesn't exist. Question doesn't even make sense. Like, I wouldn't even ask this, right? If I asked that, it would be a typo. So technically it doesn't exist, but it sort of doesn't exist in this ridiculous way where there's nothing there. If I graph this, there's nothing there. That's not part of the domain. So I wouldn't ask that in this particular question, but you do have to be aware of such things. Okay, one other point I wanted to make about vertical asymptotes. We also have other functions that have vertical asymptotes, not just rational functions. For example, natural log of x has a vertical asymptote at x equals 0. If I look at tangent of x, or of course I have these asymptotes here, at pi over 2 minus pi over 2, etc. So any function that is, but both of these functions are continuous, right? So we already said we can pull the limit in because it's a continuous function. It's continuous everywhere on its domain. So I can use that if I have, say, limit as, I had something like this, x goes to 5. Okay, something like this. Notice that it's 5 minus x. Actually, if I graph this, it's like, here's 5. And it's like this. So graphically, I can see that the limit is going to negative infinity. Or if I do a sign chart, it's 0, function is 0 at x equals 4 because natural log of 1 is 0. And so my sign chart is like this. So I can see that as I'm going from the left, I'm going to negative infinity. So either way would tell me that that's negative infinity. So it just gives you some idea.